Okay, we're going on with part three of chapter 21 on musical sounds. And let's dismiss my image. And we're going to talk about there's different ways that music is made. Number one, by vibrating strings, piano, guitar, violin, cello, uh, harp. The other is vibrating air columns. The your brass instruments, saxophone, trumpet, flute, clarinet, uh, pipe organ. We'll discuss the resonances in pipe organs in a minute, and then percussion. Drums, congas, all sorts of percussion instruments. I mean, even um, some that don't necessarily have a skin, just you might have a gourd that you strike with a stick. That's a percussion instrument. So first, we'll discuss vibrating strings. The vibration of stringed instruments is transferred to a sounding board, and from there to the air. You look at a typical guitar. It's mounted on a a hollow box, and that allows the sound to be amplified. Vibrating air columns. Brass instruments is air set and vibrating by the musician's lips, resonate through a tube. Woodwinds, a stream of air produced by musicians sets a reed vibrating. Your saxophone, your clarinet, they have a reed. The oboe has a reed. Fifes, flutes, and piccolos. The musician blows air against the edge of a hole to produce a fluttering string. And then I think it goes to percussion, striking a two-dimensional membrane. Tone produced generates, yeah, the tone produced depends on geometry, elasticity, and tension in the vibrating surface. And the pitch is produced by changes in tension. So let's, I mean, so, I used to, we attended a Poncho Sanchez, who's a percussionist concert, and he would, as he's playing his congas, he would lean his elbow under the conga and strike it with his hand, and you could hear the change in pitch. He's putting his elbow on the skin of the conga, making it changing uh, the tension in the skin. I'm going to stop the share. Or actually, I'm going to switch shares and go to, hopefully I can find my Mathematica demonstration. And I always lose these things. Where is my, there it is, Mathematica. Okay. This is a resonance in a closed pipe. Now I had earlier drawn a line across here so that to make it look like a closed pipe. Your resonance depends on whether your pipe is closed or whether it's open. If it's closed, down here the air molecules, if it's closed at this end, the air molecules can't vibrate. They're kind of stuck. Whereas here is the open end, they're free to vibrate, and so you get the maximum vibration at the open end. A node at the closed end. Again, you're gonna have to imagine that this is closed, but for some reason my line didn't come out. And so when you have the fundamental, this is actually just a quarter wave. In other words, if you were to do a full wave, you would come up here to the peak, and then the crossover, come down, and then another crossover, and that would be a full wave. So this is only a quarter wavelength. And the harmonics that you produce are odd harmonics. So if we increase it, hello, why don't you? There you go. Oop, it did it twice. Okay. See, this is a 3/4 wave. We haven't completed a full wave. So we have the first, the 3/4, and we do it again. Now we have a full wave, but now we have 5/4, 5/4. There's 1, 2, 3, 4, 5, 5/4. We can keep going. And there's how many do we have? 1, 2, 3, 4, 5, 6, 7. So you can see we have the odd uh, quarter lengths. There is no even quarter lengths. So this is how we get resonance inside like a pipe organ that's closed at one end. You can make a little pan pipe with, so I made them with soda straws and just put little Elmer's glue on the end of the soda straw, and you have to cut them to size, and you can make a little pan pipe. I know back at River Center Mall, there used to be I don't know, it was Peruvian band that used to play on the, that little where the boats come around at River Center Mall, and they'd be playing their pan pipes. It was pretty cool music. I don't really remember where they were from. But anyway, this is the way the resonance sets up in a closed pipe. Now, for an open pipe, now you're going to have to imagine that that this is open and this is open. Now, if it's open, oh, well, let's go back here, and you can see. Let's see. I think I went too far. Yeah, resonance in a closed pipe. What was the point I was going to make for going back here? I forgot. Oh, I just the nodes and antinodes. Like here with the what did I say? There's seven fourths. You have 1, 2, 3, 4 nodes, and 1, 2, 3, 4 antinodes. So there's a resonance in a like a closed pipe organ. Again, you have to imagine this line here. Why it didn't show up? I even have the infinite line, plot style thickness 500. It didn't add the vertical line. Anyway, let's go now. Forget that this is closed. It's actually open on either end. And if it's open on either end, the molecules are free to vibrate on this end, and they're free to vibrate on this end. And so this one, this is a half wave. From here to here, it's a half wave. You go up here again, it's a full wave. So now, now this is a full wave. Down and back up. You see, from here to here is lambda, a full wavelength. So we had a half wavelength, a full wavelength, and we have 1.5 wavelengths. So this one has both odd and even harmonics when you have an open organ pipe. So it's going to sound different if the organ pipe is closed or the organ pipe is open. It's going to produce different harmonics, and it's going to sound different, even if you were to have them at the same pitch, at the same frequency, fundamental frequency, because they generate different harmonics. It'll sound a little different. Okay, I think that's it for the demo. This is an open pipe, and this is this is a closed pipe. Okay, let's go back to the new share. Let's go back to the PowerPoint. That's not it. Oh, here it is. Okay, we went through that one. That's percussion. Let's see, make sure. Electronic musical instrument differs from conventional music instruments, and it uses electrons to generate the signals that make up musical sounds. It modifies the sound from an acoustic instrument. It demands the composer and player demonstrate an expertise beyond the knowledge of musicology. One of my first jobs back in I guess in the 73, 74 was actually at the recording studio, and I can remember when the owner of the recording studio brought in a synthesizer. It was one of the first. I mean, it's when the synthesizers were very early. They had all sorts of controls where you could control the pitch. You could control the attack. You could control the fade. I mean, it looked very complicated. I didn't really touch it. I wasn't a musician. I was a technician. In the recording studio, I would wire the patch panel and wire up amplifiers, things like that. I wasn't a musician, so I let the musicians play with the synthesizer. They would get some weird sounds out of it. Um, so electronic musical instruments are very different than acoustic musical instruments. Of course, you know that. Um, let's see. Here, this is just an interest. This is uh, a record player. This is the grooves of a record player. And this is the record player needle. And this is what the grooves of a record player look like. They actually have the waveforms that make up the music uh, on either side of the groove. Now, they don't necessarily look the same, right? You would think that they would be symmetrical. No, they're not symmetrical because these were capable of playing stereo music. So on one side you get what would be played, let's say, on the left speaker, and here on this side you get what is on the right speaker, and so you have a stereo effect. So they're not necessarily symmetrical, and so the one side would vibrate. It's either a little crystal or a little magnet and turns it into electrical signals, and that in turn it goes to an amplifier and goes to a speaker and gives you your sound. So these are the grooves in an album. We used to call them LPs for long play, a record. I still have a collection of records. Nowadays, I just have iTunes and uh, listen to my music on iTunes. You can get just about anything you want on iTunes. Not everything, but the selections are amazing. Okay, and I think that's the end of part 3. We'll stop it here.